Hey everybody, welcome back to the lab. As we discussed in the last video, we're now going to take measurements of this fluid system to try to calculate the resistance in this pipe. In order to do that, we need a few different numbers. We need to know the pressure change as the fluid passes from the right to the left. We also need to know how much fluid is actually passing through the system. Now, we can't measure the pressure in this pipe directly, but we do know that we can use the water level in these standpipes to determine the pressure at various points. We're going to do two examples here. One where the valve is mostly open, so lots of water is allowed to flow through, and one where the valve is much more closed, so that the current is much less. We'll start with the example with the valve open. Alright, you're going to want to write these down, so make sure you have a pencil and paper ready. Going from right to left, we have 46 centimeters, 35.5 centimeters, 27 centimeters, 17 centimeters, 12.3 centimeters, and 8 centimeters. The other quantity we need is the amount of water flowing through this pipe. The way we're going to do this is by using this large graduated cylinder. When this water flows through this system, it passes through this pipe and falls back down into the bucket. We're going to temporarily redirect the flow of water into this graduated cylinder. If we do this for a specific amount of time and then measure how much water is in the graduated cylinder at the end, we can determine how much water is flowing through the system per second. I held this graduated cylinder under the flow of water for 5 seconds, and we amassed 360 milliliters of water. You should be able to use that to determine the current flowing through this system. We're going to do this exact same experiment again, but with a much lower current. All right, I'm going to do the same measurements all over again. All right, I'm done with the measurements for the low current case. Here are the numbers. From right to left, we have 59 centimeters, 53.3 centimeters, 49 centimeters, 44.5 centimeters, 42 centimeters, and 40 centimeters. I again let water flow into the graduated cylinder for 5 seconds. This time, however, we only ended up with 240 milliliters of water. There's one more measurement we need before we can calculate the resistance in this pipe. In general, when we calculate resistance, we want to calculate the resistance of the pipe per unit length. We can calculate the resistance of the whole pipe, but what happens if we get a new pipe with a different length? We'd have to start all over again calculating the resistance. By calculating the resistance per unit length, we can generalize our measurement to pipes of arbitrary length so long as they're made of the same material. We've already taken all the measurements we need to calculate the total amount of resistance between this standpipe and that standpipe. Let's now measure the distance between them in order to calculate the resistance per unit length. I measure that distance to be 91 centimeters. Using all these numbers, you should be able to calculate the total resistance in this pipe. work with your classmates and your TA to figure out how best to do this.